Hello there. Today we're going to have a look at the fourth and final key area of the electricity unit at National 5 Physics, electrical energy and power. And we're going to start by defining that power is the energy transferred per second. So this here is the rating plate for a Black & Decker sander. And you can see on the rating plate it lists its power rating as 240 watts. That means that it will take 240 joules of electrical energy and turn it into 240 joules of kinetic energy and a bit of sound every second. 1 watt is equal to 1 joule per second. And that brings us to the formula for power equals energy divided by time. Power measured in watts or joules per second. For example, a heater supplies 3000 joules of heat energy in 5 seconds. What is its power rating? So the formula, power equals energy divided by time. 3000 joules divided by 5 seconds gives us a power rating of 600 watts. Now, we can also calculate electrical power by multiplying the current flowing in an electrical circuit by the voltage across the component that we're dealing with. P equals I times V. So, for example, another electric heater is rated at 3 kilowatts and is connected to a main supply of 230 volts. What is the current that flows through it? So, we can use that formula, P equals I times V. Our power is 3 kilowatts. Kilo is the prefix for times 10 to the power of 3. So 3 times 10 to the power of 3 equals I times 230. So current, I, is 3 times 10 to the power of 3 divided by 230, which is 13 amps. Now, an electrical fuse is used as a safety device to stop too much current flowing through a device and causing damage to the electronics in the device, or indeed causing overheating and the potential of a fire. How it works is, a thin piece of wire is designed to melt and break if the current passing through it rises above a certain level. Now, the two normal fuses that we use in our appliances in the UK are 3 amps and 13 amps. And as a general rule, appliances with a power rating less than 720 watts will need a 3 amp fuse, and appliances with a power rating more than 720 watts will need a 13 amp fuse. There are 2 more formulae that deal in electrical power, and these are really just hybrid formulas that are combined between the Ohm's law formula, V equals IR, and the power formula, P equals IV. And we can combine them in 2 different ways to give us these 2 formulas. P equals V squared divided by R, so power is voltage squared divided by resistance, and P equals I squared R, power equals current squared times resistance. So one more example. The heating element of a hairdryer is supplied with 920 watts of electrical power at a current of 4 amps. A. Calculate the resistance of the element, and B. What fuse rating should be used in the plug for this device? So, A. We know the power and the current, and we want to work out resistance. So the most sensible formula to use is this one, P equals I squared times R. Power is 920 times I squared, which is 4 squared, times R. So resistance is 920 divided by 4 squared, or 920 divided by 16, which is 57.5 ohms. Part B asks me to state which fuse rating should be used. Now, if you remember back a few slides ago, the rule was if the power rating is less than 720 watts, we would use a 3 amp fuse, and if it is greater than 720 watts, we would use a 13 amp fuse. So as the power rating is greater than 720 watts, we would use a 13 amp fuse. Okay, so that brings us to the end of this video about electrical energy and power, and also brings us to the end of the electricity unit at National 5 Physics. I hope you found these videos helpful and that you'll watch some of the others on the other topics. Until next time, bye for now.